Hey guys, it's Obi here. We are going to start talking about day 2 of air conditioning systems. Before we do that, I want to give everybody a heads up and let everybody know. First off, I did get my tablet fixed, which is nice. Was not very happy. My kid decided to try to put my password in about 20 or 30 times, I'm not sure. But he definitely did it enough to entirely lock my iPad out, where I had to connect to iTunes and refresh it, I guess is the proper word. So we did get it done luckily yesterday. Wasn't too bad of a process, but don't want to do it again. Also, the other thing I want to talk to you guys about. So here's the official word we got from administration yesterday that they wanted us to do. So if you did not get assignments completed, we exempted you from the assignment. And then you have to complete it this quarter. So the way this will work is if you did not complete the assignment in the third quarter, we basically exempt you from the assignment, and then we have to put all of those assignments in the fourth quarter. Now, the fourth quarter, this one, there's no holds barred, anything like that. So you guys have to get your assignments done in the fourth quarter, or you will not pass the quarter. Okay? This doesn't affect most of you guys. There's only a couple of stragglers that we run into an issue with, but I just want to let you know you got to make sure you keep these assignments done. That's the only way we have to give you guys any credit, and I assume you all know by now, but the last word that I got yesterday was that we are going to continue this until the end of May as of right now. So just wanted to give everybody a heads up. We got a good long road ahead of us, okay? So anyways, to continue on what we're doing today, we are talking about automotive air conditioning system operation. So specifically, we're going to be talking about distribution systems. Now, if we remember on, I believe it was Friday last week, we talked about the airflow control section, and that meant that we were going to decide whether we were recirculating air into the compartment, or from the engine compartment, from the interior occupant compartment, let me say that right, and then pressurizing that air with a blower motor. And then that leads us into the temperature control section right here. So this is what we're going to talk about today. And I want to start off by talking about the first component we're going to get to. No, I don't. I want to start talking about what the temperature control section is. So the temperature control section contains everything necessary to change the temperature of the incoming air. It really is going to include the following components, okay? So first and foremost, it's going to be the evaporator core, which cools and dries the incoming air. The heater core, which warms the incoming air. And then the temperature blend door. This is going to allow the outgoing air to reach any temperature between full hot and full cold. Okay? Okay, so now the first component we're going to get to in the system is the evaporator core. So this is an evaporator core. It's going to look pretty similar to a heater core, but I want you guys to notice, in fact, here, let's take a jump over and let's look. This is a heater core. This is an evaporator core. Heater core, evaporator core. So there is a couple differences. I know they both look like big chunks of aluminum with fins in them, but if you guys can tell, it's hard to see in this picture, but there is actually one tank here and another little tank here. So there's actually two separate tanks welded onto this one. And the big easy way for us to be able to check, or to be able to tell that this is going to be the evaporator core, if we see these pipes right here that come up to this little block. So this is a connection to our expansion valve that we're going to learn about later. So if you see this, it's pretty well a dead giveaway that it is going to be part of the AC system. Okay? The evaporator cores are pretty much always built out of aluminum. I can't tell you the last time I've seen one in a different color. Usually the evaporator cores themselves are built out of aluminum. Okay? So as I said earlier, all of the air is going to have to come through the evaporator core. And the reason it is called an evaporator core is that the coolant the Freon, I'm sorry, is actually coming through this, and it is going to be coming into one tank, going across these fins, and then what will happen is as it's going across this, there's a pressure drop inside there, and the coolant itself, or the Freon itself, begins to boil. And when the Freon boils, it drops in temperature drastically, and that forces or allows the incoming air to be cooled. So we're absorbing the heat from the air and then absorbing it into the aluminum for the evaporator core. We'll learn more about how that process works when we actually get to talking about the HVAC system itself, or the AC system itself. But this is going to reduce the temperature of the incoming air, okay? Now there's one important thing I want to talk to you guys about. We talked last Friday about a cabin filter. And you see this cabin filter is really nasty and has a lot of fuzzies and all that. Well, there's one really good thing about that. Well, a couple really good things. One that we talked about before, this isn't getting into the occupant compartment now, which is really nice. But if we have that cabin filter, it eliminates the chance for AC evaporator to look like this. Okay? So if we don't have a filter in our vehicle and we are driving in dusty environments, something is probably going to collect that. So one thing about the evaporator is that we actually, when we have a drastic drop in temperature, we are going to condense water out of the air, because the air can only hold so much water, and the amount of water it can hold is based off of the temperature. So the higher the temperature, the more moisture it can retain. As that temperature drops, we get what's called a dew point. And the point at which it has 100% humidity and it starts to condense or drop liquid out of the air is called the dew point. So once we get below that dew point, we're going to start dropping water off of it, which is why we have to have an AC drain and why you always notice water underneath your car when the vehicle's running. The downside is that moisture is dropping off of the evaporator, so it's kind of a wet environment right here. And what we're going to see is those little dust particles are going to start getting stuck in that moisture. And eventually it cakes up. So if we see a really reduced airflow and we don't have a cabin air filter, then unfortunately the next thing I'm probably thinking is I'm going to try to get a borescope or something in here and see if I can see the evaporator, because there's a good chance that we got something going on that's going to look like this. This is a fairly common thing. Most vehicles now do have air filters, as long as somebody didn't take it out. But this, especially in work vans where they are in pretty dusty environments continually, this is unfortunately fairly common. Okay, so the next thing I want to do is talk about a heater core. So the heater core is a little bit different. If we notice, we only have one tank on the top and the bottom. It's physically a little bit thinner. And we see we just have two heater hoses coming off here at top, okay? So this is connecting right into the cooling system, and we're just going to have coolant flowing through this. And this is going to act exactly like a small radiator. Basically, this radiator is just inside of the vehicle, so all of the heat generated by the engine has to be dissipated somewhere, and the radiator does about 90% of that. 100% of that if it's in the summertime. The thing is, with the radiator, that heat is getting wasted. We're not able to use that energy for anything helpful. However, when it's cold outside, we run a fan through the heater core, and we're actually able to utilize some of that heat energy. Okay, so we're using the heat produced from the engine to heat the occupant compartment to maintain comfortable temperatures inside the vehicle. Okay, so with the heater core, usually there's a couple ways we're going to see this fail. One way is that we're going to see a leak somewhere in it. Typically that happens with the solder joints, where these little metal tubes actually go into the tanks. One of those solders will start to leak, and eventually we'll see coolant getting in the floor wet inside the vehicle. So we'll see it fail that way. And the other way we'll see it fail is by actually the heater core itself getting plugged. Okay? So when I say a heater core is getting plugged, what I mean is that debris and just general dirt and crud and grime gets into the cooling system, and it actually starts to plug these little fins up. So if we see these tubes, they're very small, wide, and flat tubes. So you can tell that this one here is actually completely blocked. This one looks like it's partially blocked, and it just gets nastier the further we go down. So if we have a heater core that does not flow properly, we have to try to back flush it first, which means we unhook our hoses and we take water and we try to actually force water. We back flush it. So we try to force it through the opposite way it runs, and we flush all this nasty coolant out. If you've ever flushed a heater core, the first time you flush it, man, it just looks nasty. It's just about brown when it comes out. Then we flush it the other direction. We go back and forth until we get nice clean water coming from both directions. And hopefully we were able to rejuvenate this heater core, okay, and get most of the dirt out. Now, I'll be the first to tell you, you're probably never going to get it 100%. There's always going to be at least one of these tubes that are probably going to be obstructed, and you just can't get it cleaned. There are other things that we can do. We can actually try to use a chemical flush. However, we do have to be careful. If we look, the tubes here are actually really thin, okay? So there's not a lot of meat going on in the side there, so that chemical flush is actually basically a weak acid. It's going to be able to attack this dirt and crud and all the other crap that's in there, and hopefully free our system up. The downside is that it will also attack the aluminum to a certain extent, and left in there too long will actually cause it to eat right through the aluminum components. So we got to be careful about that. You got to make sure you follow directions when you're doing a chemical flush. Not that it doesn't work, it's just we have to be careful about it, okay? But so the two big failures for a heater core is going to be if the system is physically plugged and coolant can't flow, and if the system is leaking externally, and we have to replace it that way, okay? So the last thing I want to talk about today is the orientation of the layout of the evaporator and the heater core. So if we look at this, we notice our evaporator is in the front. So the first thing that the air system is going to get to is going to be the evaporator. And we can also tell that 100% of our incoming air is going to have to go through the evaporator. All the air has to go through there, okay? But then, depending on what temperature we want to come out, we actually have these things called temperature blend doors. And the blend doors can either be fully, let's say, open, where we are forcing all of the air to go through the heater core, or closed the other way, which blocks all of the air out of the heater core and allows or forces all of the air to bypass the heater core, okay? So the reason we force all of the air to go through the evaporator core is because if we're going to use our defrost setting, we're actually going to want to cool the air down before we heat it up. And that seems a little bit counterintuitive, but the reason we do that is because when we cool the air down, we actually take all the humidity out of it, and then when we warm it back up, it's really dry air, which means that it's going to do a really good job of taking the moisture off of the windshield, okay? If you don't have the evaporator core working, a lot of times when you just run the heat, it'll actually make the window frost up, which is the opposite of what we want, or fog up, I guess is what I'd want to say. So we always want our air to go through the evaporator core and then through the heater core if we need it, okay? All right, guys. I'm pretty happy with this. Tomorrow we're going to talk about the distribution system itself, and we'll talk a little bit more about those temperature blend doors or the actuators that run them. Okay, so I will talk to you tomorrow. Obi out.